Hi everybody, this is Mr. Horvath. First off, I hope that everybody's feeling healthy and that you're staying away from this coronavirus and staying inside. We're going to go through the front half of the guided notes today on partial fractions. And this is a rough, just to give you a heads up, it's a rough topic for e-learning day one. So if you have questions, I'll be available every day between 9 and 3. You can send questions through Remind, you could send questions through Microsoft Teams, or by email. So what we're trying to do is really the reverse of this warm-up 2 here. So hopefully you tried both of the warm-ups before playing this video. Here we're finding a common denominator to add these fractions together. So we started with 2 over x plus 1 over x minus 2. We ended up with 3x minus 4 over the common denominator. With partial fractions, we're going to start with the answer and we're going to try to break it up into 2 fractions that add or subtract to make that. And this is a topic that will be used in calculus. So on the back, we'll actually be breaking it into these fractions just to kind of progress to that. We're just going to write the terms for partial fraction decomposition with this example here. So the first step is to factor the denominator. That's done for us right here. The denominator is x to the third times a factor x plus 3 times a factor x squared plus 1. And here's the important part. We want to write each factor as its own fraction. So x to the third, x plus 3, and x squared plus 1 are going to be their own separate fraction. And then the numerator needs to be 1 degree less than the denominator. So let's put an equal sign and break this up. We're going to start with the x plus 3. So that's going to be on the denominator. Okay, I ask myself, what's the degree of the denominator? And the degree here is 1. So the degree of the numerator should be 1 less than that. That would be 0. All right, so 0 is just a constant. So I'm just going to put a variable there, and we usually go in alphabetical order. I'm going to put a there, and it'll just be a number when I actually do find it on the back side. All right, so plus, and then we're going to go to x squared plus 1. Now the degree of the denominator here is 2. So the degree of the numerator needs to be 1 less than that, and that would be 1. All right, so that means I need an x to the first power up there. And if I have an x to the first power, I can also have a constant after that term. So we're going to write this as b, the next letter after a, times x, plus our constant, and the next letter we use is c. Okay, next up is x to the third. Now, for repeated factors, and x to the third is really x times x times x. So my factor of x is repeating 3 times. I form fractions containing increasing powers of that factor in the denominator. And I like to call this building up. We're going to build up. All right, so we want to make x to the third by the end of this, but we need to start with x to the first power. And then we're going to increase powers to 2 and increase powers to 3. So the degree here is 1. So on top of that, I want degree 0. We're going to go with the next letter, that's d. And now we're going to build up. So we need x squared. And after that, we need x to the third. Now our quantity here is actually just x. So I'm going to consider all of these to be degree of 1. Okay, the power is from building up. So degree of 1, the numerator would be degree of 0. We're going to put an e here, and we're going to put an f. If we had had like x squared plus 3, and we were building up and raising that quantity to a different power, now the inside has a degree of 2, so I would have to put a degree of 1 on the top. All right, so examples. Write the terms for the partial fraction of each. So the first thing we want to do is factor the denominator here. It's not factored for us. Hopefully you know that x squared minus 4 factors to x plus 2 times x minus 2. Okay, and and we're going to write x minus 14 on the top there. And then we're going to break this up. These are not exactly the same, so I don't have a second power. I'm not building up. I'm going to write each factor separately. Okay, and now I find the degree of each. Each one has a degree of 1. So I want degree 0 on the top, which means I'll start with A on the first fraction and B on the second fraction. And again, we're progressing. On the back side, we're actually going to use a method to find A and B so that you'll have the numbers that go on the top. Okay, and number 2, factor the denominator. Here we have a common factor of x squared that's in both. So I pull that out, I make a parenthesis with what's left, and I would be left with x plus 2. Okay, we'll break it up. So here we're going to have to build up. We have a quantity of x being raised to the second power. That's a repeated factor. It's really x times x. I'm repeating a factor of x. So we're going to start with x, and then we'll build up to the x squared, and we're going to consider both of those degree 1. Again, the quantity here has a degree of 1. So we'll call those A and B, and then we need to use the factor of x plus 2, and that's degree 1, so we're going to have degree 0 on top, and that would be C. So we're going to have A over x plus B over x squared plus C over x plus 2. And these could be arranged in any order. Addition is commutative. All right, and number 3, why don't you try that one on your own and check your answers on the filled-in notes.